Alright, so let's talk about how to use hypothesis tests to make decisions. A hypothesis test is useful for making decisions about our data, but how do we decide to reject the null hypothesis? How can A and D decide whether the power solvent results in a fuel consumption that differs from the industry standard of 3.10? Okay, so we should use hypothesis tests to make decisions. Consider this output from a one-sample t-test. When we conduct a hypothesis test, our results include a test statistic and a p-value. This is a test statistic and this is a p-value. We use p-value to determine whether we should reject or fail to reject the null hypothesis. Let's examine test statistics and p-value graphically using a directional or one-sided test. The, this area represents the probability of rejecting a null hypothesis that is true. This probability is called alpha. We always select it before performing the hypothesis test. Let's examine alpha for a two-sided test. In this case, alpha would be even split on either side of the distribution because the alternative hypothesis considers the possibility of observing values on either tail of the normal distribution. Recall the confidence level that we discussed earlier. The confidence level is how sure we are the confidence interval contains the true population parameter value. The confidence level equals 1 minus alpha. Let's return to the one-sided test. Recall the output from one sample t-test. We need to consider the location of the test statistics in relation to alpha. Each test statistic has an associated p-value. It is probability of obtaining a test statistic that is at least as extreme as the calculated value if the null hypothesis is true. If the p-value is less than or equal to alpha, reject the null hypothesis and the results are statistically significant. Suppose uh, alpha is 0.05. So what if the p-value is 0.032? Would we reject or fail to reject the null hypothesis? So in this case, we would reject a null hypothesis because the p-value is less than alpha. So what if the p-value is 0.076? So in this case, we would fail to reject the null hypothesis because the p-value is greater than alpha. Let's return to the power solvent example. The R&D team wants to test whether the use of power solvent results in a mean fuel consumption of 3.10 if alpha is 0.05 and the p-value is 0.001. Should we reject or fail to reject the null hypothesis that the mean fuel consumption is equal 3.10? Okay, so in this case, we reject the null hypothesis. because the p-value is less than 1, so the results are statistically significant. The p-value indicates whether our results are statistically significant. However, just because our results are statistically significant doesn't mean that they are practically significant. To examine practical versus statistical significance, let's consider the production process at a company. So can the company reduce production time to get the power servant in stores more quickly? The production line manager attempts to reduce production time by modifying the process. He compares the production time of the old process with the production time of the new process. The p-value is 0.032 using an alpha of 0.05. Should we reject or fail to reject the null hypothesis? The answer is we should reject the null hypothesis because the p-value is less than alpha. So we reject the null hypothesis that the production times are equal. The results are statistically significant. Now consider practical significance. If the difference between the two production times is 5 seconds, is that really practical significant? Is that really practically significant? Is it worth the cost of implementing the process change? Maybe, maybe not. Always consider the practical significance of your results and your knowledge of how the process before reaching a conclusion. We can also use confidence intervals to assess practical significance. Remember that a confidence interval contains the likely values for a population parameter. For example, the confidence interval is 4.23 to 5.74, indicating a likely difference in production time between 4.23 and 5.74 seconds. The production manager must use her experience to determine whether this difference is meaningful in the context of this production process. Let's review. A hypothesis test generates a p-value which we can use to make a decision about the null hypothesis. If the p-value is less than alpha, we would reject the null hypothesis. If we reject the null hypothesis, the result is statistically significant. We can use our knowledge of the process to interpret the practical significance of our test result. Thank you for listening. In the next lesson, we will talk about type 1 and type 2 and errors and power.